In this video, I'm going to demonstrate how to solve multi-step equations with combining like terms. The learning target is, I can solve a multi-step linear equation with combining like terms. The language target states, I know I can do this when, given a multi-step linear equation with combining like terms, I identify the like terms involved, combine the like terms, and then isolate the variable by moving everything else to the other side using inverse operations and moving what is furthest from the variable first. I know I have a final answer when I can write it as a variable equal to a constant or number term. Before beginning my work, I must read the directions, which state to solve each equation. Taking a look at example 1, I'm going to clearly show the left side of the equal sign and the right side of the equal sign so that I can ensure my equation remains balanced. Whatever operation I perform on one side of the equal sign, I must perform on the other. The first step is to determine whether or not there are any like terms to combine. If I look at the left-hand side of the equal sign, I'm noticing that there is a single number 5 all by itself and nothing else. So I probably don't have anything else to combine it with on this particular side. However, if I look at the right-hand side, I am noticing that I have a positive 4x and that I also have a negative 3x. I'm going to either highlight them both in the same color or box them to indicate that they go together, they're like terms, I can combine them. One of the biggest rules when combining like terms in the context of solving equations is to say same side, same signs. So as long as I am not moving a term or terms from one side of the equal sign to the other, I should simply use the signs, positive or negative, that I see in the original problem without changing them. As I look to simplify the right-hand side of the equal sign here, I am noticing that I see a positive 4x combined with a negative 3x. I can treat that either as 4 with subtraction by 3 or as 4 added to negative 3 because adding the opposite is the same thing as subtracting. Before I type anything into the calculator or use a number line to computate, it's always a good idea to take a look at the original problem as well. In the original problem, I'm noticing an implied positive 4, so there's a single positive sign, and only one negative or subtract sign. If I look at both of these options, I'm also seeing only one negative or subtract sign in each. Let's contrast that with this. If I accidentally did 4 subtract negative 3, I would get the incorrect result and also notice that I had 2 negative or subtract signs, whereas in the original problem there was only one. Therefore, this cannot be a correct way to combine those like terms. If I have 4 x's and I take away 3 x's, the result should be a certain number of x's. Let's take a look at the original problem again. I'm noticing as I work from left to right here that there's no math for me to do on the left-hand side, so I'm simply going to write that 5 again because it is still part of our problem, and now I'm going to write the equal sign. When I combine 4 and negative 3, again I can always do extra add signs but never extra subtract. The result is a single x. 4x take away 3x is 1x. At this point, I know I've solved because there's nothing else attached to the x. It's completely isolated and by itself on that side of the equal sign. But in order to make the final answer clearer for my reader, I am simply going to write the x, or the variable, first, equal to 5, and that is the solution. Let's take a look at question 3. Once again, it's always a good idea at the beginning to clearly show the two different sides of the equal sign so we can keep the equation balanced. On the left-hand side, I'm once again noticing that I have a number that's all by itself, but nothing else that goes with that number. On the right-hand side, I'm noticing that I have a positive 4 and a positive 6. The 4 is an implied positive, and the 6 actually has an add sign in front of it, so I know for sure it's positive. I can either highlight them in the same color or circle them. Next, I'm going to identify my variable term or terms. In this case, it's a single term, negative 7x, all by itself, so I'll box it. As I scan from left to right, I'm noticing that all of my symbols, my addition and subtraction signs, are included with a particular term, so I'm ready for the next step. I didn't do anything with the 3 on the left-hand side, so I'm going to write it again, and I'm going to write the equal sign. At this point, it doesn't matter exactly which terms we write first, but I'm just going to work from left to right here, which means I can combine the 4 and the 6. 4 added to 6 is a positive 10. And since there's no other x term for me to combine the negative 7x with, I'm simply going to write negative or subtract 7x. From here, I want the x for my variable to stay and everything else to go away. So I know that I need to move the 10 and that I need to move the negative 7. I'm going to move what is furthest from the variable x first, which is the positive 10. I know it's positive because it's implied. Therefore, in order to move it, its inverse operation would be subtraction or negative. Whatever I write on one side, I must write on the other, and I'm ready to do some math. As I'm simplifying from left to right, 3 take away 10 is negative 7. I'm going to write the equal sign. 10 take away 10 is 0, which is exactly what we wanted to happen. It cancels out. And I haven't done anything yet with the negative 7x, so I'm simply going to write it again. Lastly, I need to undo this invisible multiplication that's occurring between the coefficient of negative 7 and the variable x. I cannot add it, I must divide because it's invisible multiply, therefore its inverse is division. I'm going to once again simplify from left to right. Negative 7 divided by negative 7 is a positive 1. On the right hand side, the same thing happening, and what remains is an x. Once again, in order to make my answer clear for my reader, I'm going to reverse the order and read the equal sign in the other direction and write that x is equal to 1. Let's take a look at number 4. Before beginning, let's clearly show the left sides and right side of the equal sign. On the left-hand side, I'm noticing a number that's all by itself. It's the number 1. I also have a similar situation here on the right-hand side, but I may not combine my like terms over the equal sign. If I want things to move from one side to the other, I must use an inverse or opposite. Another thing I'm noticing, however, is that I have a negative 7x and a positive x, and I can combine those two together because they're like terms. They have the same variable and exponent or power. If I just work slowly from left to right here, I'm not doing anything with that positive 1, so I'm just going to write it. Now I'm ready to combine negative 7 with 1x. I know that's 1x because there's no number there in front of the x. Negative 7 added to 1 is negative 6, and then I include the x. I'm going to write the equal sign, and I also keep the 1 that's from the other side. Once again, two-step equation where I want the x to stay and everything else to go away. So the 1 needs to move to that side, and so does the negative 6. I'm going to move the positive 1 first because it's further away. I move it by subtraction. Since it's positive, I write it on both sides. 1 take away 1 is 0. That's what we want to happen. I'm now going to write the negative 6x because I haven't done anything with that yet. And on the right-hand side, 1 take away 1 is 0. Once again, this is negative 6 multiplied by x. I know I must undo multiply, or the inverse of multiply is division. I'm also going to make sure that I divide both sides by that negative 6 and not a positive 6. On the right-hand side, I have a single x left, and on the left-hand side, 0 divided by negative 6 is 0. That's the solution. Let's take a look at number 6. Once again, it's always a good idea to clearly show the left side and right side of the equal sign. This time I'm noticing that I have two x terms that will go together. I'll box them or highlight them in the same color. And then I have some numbers that are all by themselves. Since they're on opposite sides of the equal sign, I may not combine them as a first step. I'm going to write the 4. Now it's time to combine either negative 7x with negative 4x. Subtracting them or adding the opposite, I will get the same result of negative 11x. And then I write the equal sign. I have not touched the 4 on the other side, so I write it down as well. Once again, two-step equation where we move what is furthest first, and in this case, that's the positive 4, which I'll move by subtraction or making it negative. I'm going to just drop the negative 11x down because I haven't done anything with it yet. And on the right-hand side, 4 take away 4 is 0. Once again, that's invisible multiplication happen, which I must undo by division because that's its inverse operation. And on the right-hand side, x is equal to 0. Let's go ahead and take a look at number 7. Once again, I want to clearly show the left sides and right sides of the equal sign. On the left-hand side, I have a negative 22 that's all by itself. There's nothing to combine it with. I have a similar situation with a number on the right-hand side where I have a negative 6, but nothing else to combine it with. For the variable terms, however, I am noticing a positive 1v and a positive 1v. Working from left to right, I'm going to simply write down the negative 22 because I'm not going to do anything with it yet. This time let's combine the v's first since they appear first. 1v plus 1 more v, or added to 1 more v, is 2v, and then I write the negative 6 down as well. From here it's a two-step. The 2 is too close to the v, but the negative 6 is further away. I want the v to stay. Since it's negative, I know I need to add both sides by 6 in order to move it to the other side. That's the inverse operation. Working from left to right, on the left-hand side there, negative 22 added to 6 is negative 14. And then I also write the equal sign. On the right-hand side, I simply write that 2v, and negative 6 added to 6 is 0. Lastly, I need to undo that multiplication that's happening there. That's inverse is division, so I'm going to divide both sides by 2. Negative 14 divided by 2 is equal to negative 7. And on the right-hand side, 2 divided by 2 is equal to a single v. I want the information in the solution to be clear, so I'm going to reverse the order and read the equal sign in the other direction and write that v is equal to negative 7. Let's take a look at an example where we have 0 on one side of the equal sign, like number 2. I am still going to show the left and right hand sides of the equal sign. And 0 is a number just like anything else. It has to stay there to anchor that side of the equal sign. But there's nothing else to combine it with, so I know it's going to stay by itself. And on the right hand side I see a negative 6. That's the number by itself, the constant on that side. I'm also noticing though a single 1n and a positive 5n. As I work from left to right, I'm simply going to write the 0 because we're not going to do anything with it yet, and the equal sign. Next I'm going to combine my n's. 1n with 5 more n's makes 6n, and then I can include that subtraction by 6. From here it's a two-step. It's easiest to move that negative 6 or subtraction by 6 first because it's further away from the variable. Working from left to right, the solution there is 6. Then I'm going to rewrite this 6n because there's nothing to do with it yet, and negative 6 added to 6 is 0. Lastly, I must undo that invisible multiplication that's attached to the n by doing division. It's its inverse operation. Really on both sides here I have kind of 1. One side I have 1 and the other one I have 1n. If 1 is equal to n, then n is also equal to 1. Let's take a look at one more example with a 0 in it. Number 5. Once again, I want to clearly show the left and right hand sides of the equal sign to make sure everything stays perfectly balanced. I see a positive 3 out in front that's all by itself, but nothing else to combine it with on that side. However, I do see a negative 4r that will be combined with a positive 1r because they're like terms. They have the same variables and exponents. Right here, negative 4r added to r is negative 3r. I'm going to write the equal sign and I'm going to write that 0 once again. Now it's a two-step. I need to move the 3 and the negative 3, but the 3 is further, so I'll move it first. It's positive. It's an implied positive, so I must subtract or make it negative to move it to the other side. That's its inverse operation. That cancels. I write the negative 3r. I write the equal sign, and I'm doing the math on the right-hand side, which says that 0 take away 3 is negative 3. Lastly, I must undo that invisible multiplication by division. That's its inverse operation. That's how I move it to the other side. And r is equal to a positive 1. And that's how you can go about solving multi-step equations with combining like terms.